Hello, this is the final project demo for the Malware Analysis Capstone project. My name is Angelia-Grace Martin, and my teammates are James Holmes, James Polson, Skylar Eade, and Robert Collins. For this capstone project, we were tasked with conducting static and dynamic analysis on a series of malware samples. Each group member was responsible for analyzing separate malware samples and constructing formal reports on those samples. The bulk of this project has been in the documentation, as our final deliverable is the finished compiled report. From the setup of the virtual environments, to the preliminary static analysis of the samples, to the dynamic analysis interacting with the behavior of the malware samples, to the research and discussion of the malware's type and intent. Each group member conducted this analysis separately on a collection of malware samples, and the final report includes documentation from beginning to end of this process. This project provided us the opportunity to build an isolated yet vulnerable virtual environment to run and analyze malware. We were able to get hands-on experience and learn what it takes to design and build the virtual environment to support the explicit needs of the project. As you can see in the screenshot to the top right, this included turning off the Windows firewall feature to fully enable connectivity between the different virtual machines so that we could fully see how a given malware sample may work its way through a network. The other screenshots highlighted on this slide include a running window of Process Monitor. Process Monitor is one of the many tools that we use during our analysis. This tool allowed us to monitor real-time file system registry and process and thread activity, so we could identify what pieces of the system the malware was affecting. A lot of the time, the dynamic analysis would involve hunting through the system based on different cues, such as registry keys being changed and processes being started, and trying to find those process IDs. So it was very much a bit of detective work with each different sample. Lastly, the screenshot on the left is from a reverse engineering tool called IDA Pro. This is a tool that disassembles compiled binaries, providing a graphical representation of the execution of code along with the disassembled code. This allowed us to get a deeper understanding of the inner workings of a given piece of malware without the need to actually run it. So it was great for preliminary analysis. As for project development, the steps we took for development might differ slightly from other capstone projects due to the nature of the malware analysis project, and the deliverable being a formal report as opposed to code and software. We first did research into what exactly would be required to support conducting malware analysis. This included what would be explicitly needed to build a virtual environment, what tools would be used for static and dynamic analysis, and how we might want to structure the reports containing our findings. We then took that research and built a design document that provided us a documented path forward for what would be required to meet the end criteria for this project. Once we had that, we worked to compile a shared repository of all required resources and actually build out our virtual environments. From there, we were able to conduct static and dynamic analysis on our chosen malware samples, and we took extensive notes as we conducted this analysis, and then from those notes, generate the required reports. Luckily, over the course of the project, we did not have any real deviations from the original plan. Everything went very smoothly with only minor hiccups that were usually resolved with just a bit of troubleshooting and debugging, and we didn't have to make any real changes. The team was effectively able to troubleshoot every issue that came up throughout the duration of the project, which mostly stemmed from working with severely outdated software and operating systems. We definitely had to do a lot of hunting down different tools and guides on the internet and troubleshooting a lot of really obscure bugs, which provided a great learning opportunity. We learned a lot through the duration of this project. Most importantly, we learned about the importance of effective communication, both synchronous and asynchronous. We all have incredibly busy schedules outside of school, so being able to document and share our research was critical to the success of the project. This included writing how-to documentation and having a shared drive where we placed new tools or other articles that describe how to better perform malware analysis. Lastly, as mentioned previously, the challenges we faced came mostly from working with outdated software and operating systems. And a lot of the times we had to tackle those together by reaching out to each other and sharing our knowledge. In conclusion, this project is just the beginning. We learned a wide breadth of technologies and gained a deeper appreciation for those working in security that are actively identifying new and emerging threats to protect users and their systems. This project gave us a solid foundation from which we continue to grow in our career, from which we can continue to grow in our careers or as malware analyst hobbyists. While there is no real commercial application to this project, we can continue building on what we have learned. Lastly, we just wanted to share our thanks for all of your help and guidance as we have worked our way through this capstone project.